So hi guys, welcome again to my vlog. So for now, we answer the chapter 7, the activities. So let's start. The first activity entitled binary to decimal conversion activity. So here's the instruction. This activity allows you to practice 8-bit binary to decimal conversion as much as necessary. We recommended that you work with this tool until you are able to do the conversion without error. Convert the binary number shown on to the octet to its decimal value. So this activity, if have a bit 1, number 1 have this value, it's multiplied by itself. If bit is 0, means the value is 0. So let's compute. So 1 1 1 plus 2 equals 3 plus 4 equals 7 plus 8 equals 15. 15 plus 32 is 77 plus 64 is 141 and plus 128 is 269. Check. Why it's correct? Let's try again. One plus 2 plus 4 plus 8 plus 64 plus 128. It's 207. Let's check. Oh, it's correct. Let's try another number. So same instruction. Let's try to 128 plus 64 plus 32 plus 16 plus 8 plus 2. It's 250. Check. So it's correct. If you see have a bit number 1, the value is multiply itself. So compute by addition this number. So let's proceed to the next activity. Next activity is ending to determine the network address. So here is the instruction. Use the ending process to determine the network access in binary to decimal. So if the host address binary, if the two numbers have 1 0, the value is 0. So for example, 0 and 1 is 0 0 0 0 1 0 1 0. As you can see, if same number is 1, automatic, that is bits is 1. So the next is 0 1 1 0 1 1 1 1. Next is 0 1 0 1 1 1 0 1. Next is 1 1 0 0 0 0 0 0. Why it's 0 0 0? Because this is 0 and this is 1. Have 1 0, it's just 0. So let's compute. Have a 10, 111, is 93 and 192. Why compute? Because this is a 1, 2, 4, 8, 16, 32, 64, and 128. It multiply by itself like this. This is the value of a bits on a position. So let's check. So correct. The binary and decimal version of the network address are correct. So let's proceed to the next activity entitled public or private IPv4 address. So the instruction is drag each IP address to the correct category, private or public. This is the IP address. The IP address. So 172.16.35.2, it is a private. Next is 192.168.3.5. It's private again. Private. 192.0.3.15. So that is a public. So 64.104.0.22. That is a public. 209.165.209.30. It's a private. 192.168.11.5. So that's a private. 172.16.30.30 is a private. And the last is 10.55.3.168. I think that is public. So let's check. It's correct. They see the public and the private IPv4 address. This is the public IPv4 address and this is the private IPv4 address. See, next activity. Activity entitled IPv4 issue and solutions. So in this activity, the instruction is drag the IPv4 and IPv6 terms to the field next to the appropriate description. So the scenario is drag the correct component on his description. So the IPv6 is 128-bit address. And next is 32-bit IPv4. Next is transport an IPv6 packet over IPv4 network. So that is tunneling. The fourth is uses NAT64 or NAT64 to convert between IPv6 and IPv4. That is a translation. Allows IPv4 and IPv6 to coexist on the same network segment. So this is the term on his description. So I think it is correct because I read the chapter 7 lesson and I read and understand the chapter 7. So that's correct. We have a last activity. Activity is identify types of IPv6 addresses. The instruction is drag the IPv6 address type of the most appropriate description. So this is the term of the global unicast, unique internet routable IPv6 addresses, and FE80, that is a link local. 2001 DB8 ACAD. That is a globe unicast. Typical IPv6 prefix used to indicate the network version of the address. So that is a 64/64. Used to communicate with other devices on the same IPv6 subnet. That is a link local. Let's check. So it's correct. We are done to chapter 7 activities. I hope you learned something from my blog. So if you have questions, just comment down and I will answer. And so thank you for watching and listening. I hope you something learned from my blog. So don't forget to subscribe and click the notification bell. So goodbye. Thank you.